Okay, so welcome to our Wednesday morning live online session recording. I'm actually starting this recording a little earlier than our scheduled normal starting time. Obviously, if someone joins us halfway through, I'll just jump back to the start and we'll take it from there. But since it's been rather quiet in terms of the attendance numbers over the past sessions that we've had together. I'm gonna make a start at this time. I have a couple of other college commitments that require me to wrap up early, so I want to make sure that we get a good recording produced for you for this session. Um, this week, we've been looking at cartilages of the body and kind of an introduction to the bone as a tissue. So this week really is a start of a larger set of lectures that we will be focusing when we look at the skeletal system. And there's going to be quite a lot to cover. But this week is kind of a smooth way to enter to that topic, smooth way to ease ourselves into the larger review of the major bones of the body. Here's the plan that I had for today's session. Again, if we had a little bit of a higher participation number, we probably would spend a little more time on that, checking and making sure that everything's working well, but we can do it also in this asynchronous manner. I'm going to mention really quickly about next week's plan, which is all to do with the exam and practical one. I don't want you to worry about it too much and then take our attention away from what's the real topic of the day, but just because I do know that few students are already looking at that and thinking of that, I want to set your mind at ease by giving you a little bit of an idea what to expect from the next week. I also want to mention really quickly about the plan moving ahead with these live online sessions that we're having. We'll do what we always do, have a quick look of what are the assignments that I'm looking for this week. And main focus will be on this review of the chapter material. And I believe it's gonna be chapter I wanted to say that it was a chapter 7, so I think that I have a wrong number there. Let me just pull it up and make sure. Yes, it should be chapter 7. So let's rectify that there real quickly. I just want to make sure that our records are accurate. So we'll talk about chapter 7 content. It's going to be kind of like a crash course type of a review of the material. And then if we have time, we might look really quickly what the homework for this chapter looks as well. As always, I want to make sure that we have time for any questions, answering at those, addressing those. Even if this is an asynchronous session, if you're not able to join me in person or in a live setting, rather, you can always send me messages. I'm very responsive through the Canvas messages. And I'll always make time if it's something that's a little more complex than just answering in writing to make that time that we can meet remotely together. So, like I said, it's important for me to know that things are going well. I'm hearing some little pieces of feedback, and it sounds that at large, things are rolling on well. I'm seeing the submissions coming in. If you kind of fall off from the map, if I don't hear from you for a while, if submissions are not coming back in from you, I usually reach out to you and just check in. Remember that I'm here to help you. It's important for me that you feel supported. I realize that many of us are juggling multiple duties. So if you ever miss a due date, don't just throw your hands up in the air and ignore that. I am usually very open to discuss whether we can extend those due dates for you, reopen any assignments, and so on. So really that maintaining that dialogue becomes important. Only times when I'm not super open to having those discussions is when it comes to the exams. So testing, we try to keep fair that we all take the exams at the same time. But like I said, my goal is not here to catch you out or trick you into anything. I'm here to help you to get whatever it is that you want to get out of this class. And in terms of the grades, I want you to know that I want to make sure that you're getting those grades that you're striving for. So, really quickly, and I will spend more time talking about the exam and practical, which are our topics for the entire next week. So that's all we will be doing next week. We will be doing testing. We'll do our first exam and we'll do our first practical. But just so you don't feel stressed about that, I'm going to mention those really briefly now. But keep in mind that you will be fully prepared. You will be receiving all the help you need to be successful on those later next week. But exam 1 will cover the chapters 1, 6, and 7. So the first chapter where we looked at some of the basic introduction to anatomy and physiology, some of the basic concepts like concept of homeostasis, some of the basic things like directional terms, body regions, body cavities. So all that material is covered in the exam 1. In addition to that, we are covering the material from our first body system, which we looked at last week, which was our integumentary system, so the skin and associated structures such as glands, nail, hair. And then this week's chapter, cartilage and the introduction to the bone tissue, will be also included in that first exam. So you'll notice what's missing from the content of the first exam is really the material that was more of aimed to be just a review. So we talked a little bit about chemistry of life. We talked a little bit about cells, a little bit about tissues, and then touched upon on the genetics. Since those were review of the material that you've covered already before on your courses, I will not be testing you on those. Exam 1 follows very closely the format that you've seen before in your quizzes. So doing those weekly activities is you preparing for the testing. And unlike the traditional quizzes, you will be taking exam 1 on Canvas. And I do have just 11 questions there. They're very similar to what you've seen before. There is a time limit to that, not so much that you would run out of time, but I don't want someone to open the exam and start reading the textbook for the very first time then. So I have set a limit of time for that, but no student of mine in the past has ran out of time on an exam. You should have more than ample amount of time to complete that. Exam carries a little bit more points than our traditional activities on a weekly homework level, and you do have to take it on one go. So once you start the exam, the timer will start running, and even if you leave the exam and come back later on, you have the duration of the time from when the exam was initially started. For this first exam, we will follow a format where it is not a proctored exam. So it is going to be for you to take from anywhere you wish at your own time on your own devices, no lockdown browser, no proctoring required for that. And I actually encourage you to have your notes available for you. So really what's important for me is that you have a good idea how to answer to the questions, and if you get uncertain about something and want to double check the answer, you're welcome to do so. So it is useful to know where you can find your answers from your notes. On that note, though, I do not think that it's going to be conductive or you're going to be able to go through every single question, start finding it fresh from the notes and study material. So I encourage you to first go based on your recollection and notes, and then the tough ones double check those. So hopefully this sets your mind at least a little bit more at ease about what to expect. And like I said, I will provide far greater review of what's coming up with the exam next week when that's the topic of our week. So this is just to set your mind at ease, set you an expectation, what you can anticipate coming up next week. Same goes for the practical. Practical covers the same chapters 1, 6, and 7. So the introductory chapter, integumentary chapter, and this week's material, cartilages and introduction to the bone. These are much more focused on you being shown images or figures or illustrations of structures and asking you to identify those structures that you're being shown. Again, practicals follow very closely of those practice anatomy home assignments that you've been given. There's about 13 questions, again, a time limit. The time limit is not there to catch you out. You will have ample time to complete the practical, but it is there just to make sure that you don't start it, leave, and come back later on. At one stage, I had students taking 4 days to complete an exam, and that's not really serving the purpose of an exam. There is, again, a significant number of points carried with the practical, and like I said, you will complete it on a single setting similar to the exam. Once you started, I anticipate that you would then complete it on that same go. This, again, is gonna be for you to take on a computer at the time of your choosing, at the place of your choosing, and you complete it on the canvas. And again, I do anticipate that if you've done your practice anatomy assignments, you will be very, very uncomfortable, very, very comfortable with the questions that come up. If there is a tough question that you're really, really struggling, you are, during this first practical exam, capable of using your notes. Again, you probably will not have enough time to look up an answer for every single question that comes up. But if you get stuck somewhere, knowing where in your notes you're going to find that answer becomes important. So I hope that if nothing else, this really quick introduction of what to expect with the exam and practical sets your mind at ease, that I'm not here to catch you out. This is gonna be covering the material that you are familiar with. So this is kind of a scaffolding approach that as you do homework, you're also preparing for what's gonna come up in the exams. Exams and practicals, I kind of use those terms interchangeably. So we will review all the things to do with the exam one and practical one in far greater detail next week. This is not an assignment that you're supposed to complete this week. This is just to set your mind at ease at this point, so you're not worried of what's to come. In terms of these live online meetings, since it's been a little low attendance, which is fine, I totally understand we have so many commitments and these are fully optional meetings. What I'm going to do moving forward is that I'm simply going to start offering these live online meetings weekly only once on Wednesday. Rather than offering it twice on Wednesday, we'll just shoot off offering these sessions at 10:30 on Wednesday mornings. I think that that's going to save a little bit of repetition from me, so I'm not telling the same stories twice a day. I will record these sessions as before, and recordings will be made available for you. So hopefully that frees a little bit more time for us to be able to focus on other things. Again, you will find a link to the live online sessions from your calendar. Initially, early part of the semester, I posted the links through announcements, but I don't think that that's really necessary anymore. You should find the links through the calendar function of the Canvas course. So nothing changing other than that I will be offering those once a day, and I will keep uploading those recordings for you. Before I talk about this week's homework, I wanted to acknowledge the great work that I saw so many of you having put in to the food for thought assignments last week. These food for thought assignments are kind of application-based questions, and I saw some really great small essays or short answers. And you should have received individualized feedback from me for each of the submission. And in addition to that individualized feedback, you will have a grading matrix that breaks down exactly what I was looking for and how you met that point. I do want to make a caveat here of noting that the grading matrix is not only always the sole base of how your final grade for that food for thought assignment on Goosebumps, for example, last week was defined. It gives us a kind of a rough idea where you fall, and then the grade can be adjusted from that rough idea based on other merits that the answer might have had. So you'll notice that it's not always one-to-one with the grading rubric and what your final grade is. I take into account multiple factors such as connecting the material to your personal life, personal relevance. If I see evidence of thought process that you had initial assumptions and maybe your thoughts changed or were confirmed, I'm looking for things like outside research of the material. I'm looking for things like structure of the answer, and I'm looking for things like references, how you included them. Remember that it's weighted roughly equal, so you have an idea how much work you should put in when you compare it to how much work you put into a quiz or practice anatomy. So if your answer was really short, it probably was hard to cover everything in a great detail of what I was looking for, but at the same time I was looking for roughly one paragraph. If you provided me more and it was obvious that you had spent some more time and effort on that, you could actually earn more than just full marks. So you could collect those extra credit points towards your work for the rest of the semester. So I'm giving that room for you to kind of choose how you collect those points, but that's an option that's available for you. If I was taking those food for thoughts assignments where I have a grading rubric available, it's visible for you even before you submit your work, I would use that also as a checklist that have I covered everything that I wanted to cover even before I submit the work. So that was from last week. And like I said, I really appreciate the great work you're doing. I really appreciate seeing the effort that you're putting into this class. This week, we have two familiar assignment types, and these assignments are in relation to the chapter 7. So we will have a look of chapter 7 quiz, and we will have a look of chapter 7 practice anatomy. So these are just a way for me to highlight the key points of the material that I'm looking for you to have taken away from the chapter materials. Remember, your textbook is the primary source of information, but I also offer pre-recorded lectures, other activities, written summaries, and so on the Canvas course and the learning modules. So there's supplementary material that might help you to tackle the learning goals for this week. So quizzes and practice anatomies are never going to be able to cover absolutely everything from the chapter. It focuses on the key points. You'll complete those through Connect, which is our publisher's platform, as you've done in the previous weeks, and the grades will then transfer over to your Canvas gradebook. Both of these assignments are due at the end of the week, so I'm asking you to complete those and make sure that you submit those by before the 1 minute before midnight on Sunday night. So it's a nice amount of points, a relatively good way to collect those points towards your final grade. So that's an activity that I'm asking you to do, and make sure that you submit. If for some reason you were to ever miss these activities, like I said before, don't hesitate to reach out to me and we'll see what we can do. Also, these quizzes and practice anatomies, like I said, is a way to prepare for what's coming up in the exam and practical test. So let's have a look of this week's learning material, kind of a crash course format. This week we looked at chapter 7, And chapter 7 starts with a review of the cartilages of the body. So what we end up seeing is that your skeleton is made of 206 bones in the human body. The number changes a little bit as you age. Some bones fuse together, so we don't have that exact number. One big message and big theme that I want to convey as part of this course is that bone is very much a living material. It's not something that gets created once and that's all you have for the rest of your life. Rather, we constantly rebuild bone, we build new bone, and we remove old bone. So bone is actually a very adaptable structure that we'll end up seeing in the body. So that's one of the big themes that I want you to take away from here. And kind of looking at the beginning of the story, one of the things that we'll end up seeing that during the development of a human body, actually we don't initially have bones, we have cartilages structures that then slowly gets ossified, slowly get calcified and turn into bone. So what we have here, we have X-ray image, I believe, of fetus, and you see how some of the bones are already present and visible, but it's especially the ends of the bones and ends of the long bones that haven't yet turned from the cartilage to fully solid bone. So we can see that in the developing human body. Here as well, we're seeing that all of these pinkish structures that are more opaque, more transparent, there's cartilageous structures. We see some parts of the long bones having started to ossify, but not fully reached that. We do end up seeing even in a newborn and in a young adult that some parts of the body, even to the old age, remain still cartilaginous. If there's a great need for flexibility, we see things like your external ear, nose tips, and so on. There are certain structures that remain cartilaginous. I think that when we think of newborns and young babies, this really explains why and how the body is able to go through that rather intense process of being born and all the things that can happen during your early life, that little bumps are far lesser of a damage to the skeletal structure because we still have that high amount of cartilaginous tissues present. When you reviewed different tissue types during early part of this course and also in your introductory biology classes, I anticipate that you saw that there are really three cartilaginous types that I wanted to talk in relation to what we see here on this chapter. So we have our hyaline cartilage, elastic cartilage, and fiber cartilage. So let's have a look of each of these a little bit more and have a look where in the body we find cartilages that fall into each of these categories. So hyaline cartilage is really quite flexible, and it is the most common cartilage type out of the ones that we review here. And we end up finding hyaline cartilage in your joints, such as where ribs join to the sternum, so the costal cartilage. That's a good example where we also see hyaline cartilage in your respiratory system. So those cartilage rings that keep the trachea open, those kind of C-shaped rings. I'm thinking where else I think we see, for example, your nose tip is made of hyaline cartilage as well. So multiple places where we see hyaline cartilage. Like I said, it is the most common out of these three in terms of the amount that we see. Looking forward, discussing a little bit more in detail, the next one that I've mentioned is going to be our elastic cartilage. Elastic cartilage is, I would describe it as more elastic in its structure. We find elastic cartilage, for example, for the structures of the external ear, and also for things like epiglottis, would be a good example of that, that we're seeing within the voice box, separating the passageway for the solids and liquids of foods from the air, kind of directing, working as that flap-like structure there. Finally, fibrocartilage is going to be the last cartilage type that we will have a look of, and we will talk a little bit more. This is really made largely of collagen fibers. It's a very strong cartilage type. We find fibrocartilage, for example, in your knee menisci, in your vertebral, between your vertebral bones of the vertebra, so vertebral discs, and also within the pubic symphysis, where the two halves of the pubis hip join together. This joint actually opens up during the birth so that we have a little bit more room to navigate to get the baby out. During this point of the class, I would normally have my students either color these structures on a diagram or build them out of a clay on a big skeleton. So I provided some of those resources for you on the handouts for this chapter, that if you enjoy of that action of noting them down on your own diagrams, you certainly have a chance to do that. Many students are kind of better learners when they're or learn better when they get to apply and do actions that relate to the material. So I want to offer that opportunity for you as well. So look for those handouts on your learning module for this content. Moving a little bit onwards, what I next wanted to do, I wanted to talk in general level about the functions of the bone. Why do we have bones in the body? And we'll go one bullet point at a time through this. So one of the things that we will end up seeing, that bones are really important in terms of their support role. They provide us kind of this scaffolding or framework where everything else is kind of hanged on. If we think what human body would be like if we didn't have any bones, we would really be this blob on the floor that would just jiggle. So it isn't really beneficial for the way we think of how humans operate if we didn't have the skeleton. Skeleton is where everything else is kind of hanged on framework for all other structures. So the support structure of the bones is the first one that I wanted to highlight. We'll also end up seeing that the bones kind of give us our shape, gives us our body form, as we can see on this sketch there. Next thing that I wanted to talk about was how our bones play important role also in protection. So many of the vital organs, vital structures are housed inside bony structures. So we see, for example, brain was enclosed or put inside this cranial cavity, our skull. So it's protected nicely there because it's such a vital structure. Same goes for the heart and the lungs. We have a rib cage around that, protecting important structures so that they're less likely to get injured or damaged. So that protective function is definitely something that we want to acknowledge when we talk about the functions of the bone. We also end up seeing, and this is really kind of relating why we start our course with, why we spend at this part of our course so much time talking about the skeleton and the bones before moving on to talk about skeletal muscles, is that really movements rely on interaction between the bones and the muscles. Most muscles run over a joint between articulation between two bones. As muscles shorten or lengthen, we can then manipulate that articulations angle. So really just having muscles on themselves would not be enough to generate the type of movements that we're seeing in the human body. The type of movements that we're seeing in the human body are greatly dependent on us having organs and insertions for those muscles, so attachment points, so we can actually manipulate the angles of these bones. So that was a third function that I wanted to highlight in terms of the bones and why bones are so important. And we'll get to see a lot more about movements of the body, how they interplay with the skeletal muscles, especially the big movement generating muscles and the skeleton, the parts of the skeleton, parts of the bones where they attach to are so tightly linked as we move onwards on our studies. I do want to acknowledge also the role of the skeleton, role of the bones as storage structures. So calcium, salts, minerals, a lot of materials are stored by the bones. So bones, again, we're seeing this very dynamic role that bones can store material and release the material based on the needs of the body. So bones are much more than just static structures that exist. They're very much of a playing role, important role in the storage of the materials for the body. I also have on this list a notion about the fact that bones are very important in terms of production of the blood and production of the blood cells. This concept is known as hematopoiesis. Poiesis, part of the word, refers to the making of. Hemato refers to the blood. So when we talk in general about production of the blood, we talk about hematopoiesis, and we see that bones play an important role as a site of production of the blood, especially when it comes to the bone marrow. So this is why if we have certain conditions where we're having issues with the blood cell production, we can look at options such as bone marrow transplants and so on. So again, we're seeing that bones are not just sticks where the things are hanged up. They're very much involved in this dynamic nature of being a living organism. I have a few other bullet points here. I don't think that they're as crucial, but I think that they're worthwhile to note. So bones play an important role also storing triglycerides, for example, an important part also in the processes of certain production of certain hormones. So there's a lot going on there. There's a lot for us to acknowledge about why bones and why skeletal system is so important. So I hope that if nothing else, this helped you to feel convinced that we really ought to spend a little bit of time talking about the bones. And the next week we will actually review each bone, or week after next week when we get to the actual skeletal system, we will review each of the bones individually. But at this point, I just want you to have kind of that big picture view that skeletal system is important, bones are important, and we saw that they were far more than what we typically tend to think on a general level. Bones are very much of a dynamic structures and play a role in the body in that sense. What I wanted to do next, I wanted to start classifying bones in few different ways. So bones can be classified in a few different manners. We'll start by looking at classification of bones based on their location, and then we'll have a look of also classification of bones based on their shapes. But one of the easiest ways and common ways how we see bones being classified has really to do with where in the body they are located. So you remember when we started our journey together of studying anatomy and physiology, and we saw that body could be divided into axial and appendicular parts. Axial part was the trunk, head, neck, and trunk of the body, and appendicular parts covered especially the upper and lower limbs. Well, the same classification approach applies also when we classify bones. Here we get into a little bit more of nitty-gritty and finer details, so I'll make sure to highlight those for you as we go along. So if we look at the axial skeleton, which is formed by your skull, your vertebral column, and your rib cage, we can almost see that this gives us this kind of a cylindrical appearance of the body. It's the long axis body that we're seeing here. So that gives us kind of protection for the structures that are vital organs, such as your brain, heart, lungs, and so on. It also gives us a kind of indication of what the body shape will be. Quite importantly here, I want to highlight how the axial skeleton continues all the way to the bottom of the vertebral column, but does not expand to the hip bones. Hip bones actually are going to be our appendicular skeleton. Same goes when we look at the upper limb, that the transition point ends so that the scapula, so the shoulder blade, and also clavicle, so the collarbone, are actually going to be parts of appendicular skeleton. So appendicular skeleton covers the bones of the upper and lower limbs, and also those girdles, those attachment points where these upper and lower limb join to the axial skeleton. So like I mentioned, if we look at the shoulder joint, your shoulder blade, clavicle, and scapula, so collarbone, if you want to disguise that with that term, they both fall within the appendicular skeleton, within the junction of the lower limb at the level of the hip. Notice how hip bones are part of the appendicular skeleton as well. So I hope that that helped to kind of clarify this. Why do we have this division into axial and appendicular body? We see a lot of these themes coming up time and time again. So it really is worth spending the time learning them the first time, because they keep repeating and repeating. Anatomy and physiology is a lot of the same structures and same concepts coming up time and time again. So it really gets easier further into the study you get into. So that was one way to look at classification of bones to axial and appendicular bones based on their location. But another way that is kind of a fun way to think about it has to do with the shape of the bones. So we can classify bones into long bones. Long bones are typically found with the limbs, so we see things like humerus or so on. Really, these long bones appear longer than they are wide. And these long bones are going to be really important. This is where we find the bone marrow. This is where we see a lot of, for example, the red blood or blood cell production in general taking place. Long bones are definitely worthy for us to recognize. If we have long bones, we're also going to have short bones. And these bones are really characterized by the short length that we see. We would have examples like we have, for example, the carpal bones or bones of the ankle. Another one that I could think of as a short bone, as a good example, would be the kneecap that we also have. So these bones, if we compare them to those long bones that we saw before, are distinctly shorter structures. So that might help us to formulate an idea of that. A third group in terms of classification of bones that we see is that we also can talk about flat bones. These are very thin bones. I think that bones that form this many parts of the skull, your sternum, so the chest bone, also scapula, the shoulder blade, would be very good examples of flat bones. So they literally appear flat, thin bones that we have in the body. And I think that this really last group that we see, which is labeled as irregular bone, is really kind of a dumping ground of classification. If a bone doesn't fit into any of the previous categories, it usually fits in nicely here as an irregular bone. So what we see here, for example, would be your vertebrae would be good examples. They are fairly varied in shape, and they really don't fall into any other classes that we've seen. So we rather classify them as irregular bones. Sometimes it can be a little hard to draw that distinction between where would a bone fall within these four categories. We have, though, had anatomy and physiology around for a long time, so we have a fairly well agreed general classification of all bones into one of these groups. But there is some room that we could debate, I guess, about certain bones. But we'll keep it with what the people doing work before us have done, and we'll respect that work and build from that. There is another way also how we could classify bones that I wanted to introduce in this at this time. We could consider bones based on also of the inner structure of the bone, or the structure of the bone, in terms of whether bone is compact or spongy. So compact bone is typically bone that's fully solid bone mass. And we find compact bone especially as the outer layers of many bones in the body. So this compact bone, the benefit of that is that it is really strong, since the internal structure of compact bone is solid. So this gives us a great strength and nice smooth outer surface. One of the downsides with compact bones is that if we have solid bones, that will add up to the weight of the bone. So we end up seeing that a lot of the large bones that we have in the body have the inner parts are made of spongy bone. So this is this kind of a honeycomb-like structure where we see that there's empty spaces within this bony material. And this really makes sense if we think about that we still have strength. It might not be as strong as compact bone, but it is still a strong structure. But more importantly, this kind of reduces some of the weight of the bone as well. So if our skull, for example, was made solely of the compact bone, our head would be really heavy to hold up, and our muscles of the neck would need to work far harder than they already have to work just to keep our head up. So what we see a lot of the time is that the outer layer of the bones is made of compact bone and inner layer of the spongy bone. So we end up seeing this characteristic appearance that we're reducing some of the weight. This is a good time to kind of take a jump and think of comparative anatomy. Think of, for example, our birds, our avian species, who generally have very light bones to reduce that weight so that they can fly. So it's easier for these animals to be able to carry the weight. So we see, for example, that that's the reason why you can put bones from the chicken, for example, after you've eaten that, to a waste disposal, and it will just grind it down. This is why you also don't really give bird bones for the dogs to chew on, because they break apart as very sharp, brittle pieces, and those can really damage your dog's digestive system. If they end up swallowing parts, they become sharp like needles or knives, and that can be an issue. So really, I just wanted to highlight that there is this classification also based on the bones structure, inner structure, whether it's compact or spongy. I wanted to talk a little bit about the structure of a bone further, and we're going to talk about structure of a bone as it relates to the long bones especially, so we'll use that as an example. So long bones can be divided into different portions. So we'll end up seeing that we have diaphysis, which is really the shaft of the bone that provides us most of the length of the bone. And at the end of the diaphysis, the ends of the bones are known as epiphyses. Epiphyses are these ends that are mostly made of spongy bone. We do have that harder compact bone outside, but you'll notice that there's a large amount of spongy bone. And we can actually separate the epiphyses, the two ends of a long bone, based on whether they're closer to the trunk, the attachment point to the trunk, so whether they're proximal epiphyses or whether they're distal epiphyses, so they're further away from the initial attachment point to the trunk. So diaphysis and epiphysis is a common way how we classify parts of the bone. But that's not by any means the only way or only parts that we see on a long bone. I want to highlight a couple of others. So we end up seeing that bones are often covered with this outside layer known as periosteum, this connective tissue that forms this outermost boundary, outermost layer surrounding these bones. We saw earlier on that we also had compact bones typically as the outermost portion of most bones, even though there might be spongy bone inside, but we're seeing that nicely on this diagram as well. And then we also see, I think that on this diagram really nicely, the cartilages that cover typically the articulating surfaces at the ends. So they provide protection so it's not bone grinding against bone, help a little bit sliding of these two bones against each other, reduce friction of the bone-to-bone contact. So cartilages might be very important, and if those end up getting damaged or diminished, then we start to see issues with the joints as well. What else can we see here? We're seeing epiphyseal line or epiphyseal plate. That is what we think of when we talk about growth plates. So this is the area where the cell division of the bone is really taking place at the fast rate, growing to both directions. This is how the length of a long bone gets added. And we can also see this cavity in the middle. This is typically where we end up finding the bone marrow in the long bones. So a lot of there to see. Let's just zoom into this little box area that I've highlighted here and have a little bit of a closer look of what we're seeing. So we're seeing that bone marrow in that cavity in the center. We're seeing layers of compact bone, and we're starting to see that compact bone is not actually on a microscopic level, just solid bone. There's a very much of a matter of building and breaking it apart, constant regeneration. We're also seeing really nicely that periosteum, that layer around the bone that I mentioned. And we can also see that there's a rich blood supply to most bones. So again, remember, bones are very much living structures. So they require a constant supply of nutrients, oxygen, and so on. So we end up finding actually a rather rich blood supply to most bones. I do briefly want to mention, and I'm not going to spend too much time on the next topic, but we're not only going to look at this course, just general bones throughout the entire body. We'll also spend quite a lot of time looking at distinctive bone markings, so various bumps and projections and depressions on the surface of the bone. So it's going to be important for us not just to name bones, but identify the important markings on the bones, because a lot of the time those markings have to do with either attachment points for other structures like muscles, attachment points for other things. We see markings left by nerves or blood vessels squeaking through either openings or depressions. We see a lot of information about other structures that might be soft tissue structures that don't remain after they have decayed, but the bone is still left there. But we can really read what's been going on from the surface of the bone. So there's going to be a lot of bone markings also in terms of the different ends of the bones. And when it comes to the depressions and openings, especially when we look at how the cranial nerves in the skull penetrate through from the brain to the outside of that vault. So there's a lot that we will cover. I will leave these though for our not next week, but the week after that chapter, where we're actually going to review some of the major bones and major parts of the bones in far greater detail. In the order to keep us going onwards and keep moving forward with the material, I also wanted to highlight a little bit about the bone tissue on the level of cells. And there's really three major cell types when it comes to the bones. I call these our O cells, referring to the osteo, so the term for the bone. So I want to quickly spend just a few moments of reviewing through those. And the first of our O cells that I want to discuss is going to be our osteoblasts. Osteoblasts are the cells that are responsible for making new bone. So they're building up new bone. Typically, what happens with these osteoblasts is that they build bone around themselves to every single direction. So on a microscopic level, you can often see that we have this circle and radiation to every single direction from that. That's how osteoblasts work and build new bone. I often compare that to if you were washing floor and you were very unstrategic about that, and you were washing floor with a mop around yourself. So that's how osteoblasts work. They build bone around themselves, but eventually they end up finding themselves trapped inside the newly built bone that they just did. So osteoblasts then become osteocytes, which are mature, if you wish to call them adult bone cells. So now they're trapped inside this bone that they just built around themselves. We end up seeing that osteocytes often have these branching parts, almost like arms, reaching out elsewhere, but they themselves end up often being trapped within the bone that they've just built. The third type of O cells that we have are going to be osteoclasts, which are responsible for breaking down old bone. So we're constantly circulating or rebuilding our skeletal structure. So osteoclasts break down old bone and osteoblasts build up new bone. That was the quick run through with different O cells to kind of add up to those. If we look at the osteoblasts, these really are responsible, since they're building the new bone, of regulating the calcium and mineral deposits in the body and so on. Like I said, osteoblasts become osteocytes then, like when they get trapped inside this new bone. I often think that they look a little bit like an octopus with their arms. And finally, the osteoclasts, which were responsible for breaking down the old bone. An interesting thing with the osteoclasts is that we end up seeing multiple nuclei, because this is actually where multiple cells have fused together to form this type of a cell. So it's really an interplay of these three cell types constantly regenerating, breaking apart, building new bone that we see in the body. And this is really what I was describing when we saw that we often end up forming these central Haversian canals and bone building around it as this kind of lamellar appearance, canaliculi, as the bones build, or the O cells build bone on a microscopic level. So it's rather fascinating to recognize that. If we look at the compact bone here, we have a little bit more of a schematic diagram. And here I want to highlight that a single osteon would be what we have around these osteoblast that has built the bone around itself. At the very center of an osteon, we often see these canals where we have blood vessels, nerves, and also lymphatic vessels running. And then we saw these arms or connections from one canal to another osteon's canal. So there is interplay in between these structures. In order to keep up with the time limit that we have, I do want to mention a little bit about the fact that bone, once it's been deposited, it just doesn't end up being that structure. It's constantly being rebuilt, breaking apart. So bones can be very responsive as well to the stressors that they're exposed. For example, if you're a runner, your bones will be constantly exposed to some level of impact, and this will actually strengthen the bone itself as it kind of responds to these changes. So going from 0 to 100 in terms of exercising is not always the solution. We want to build up so that your body can be responsive to the changes that we're seeing. So that's what I'm trying to communicate with this picture, and this kind of a cyclical nature of these O cells that we just had a look of. What else are we seeing on this picture? We're seeing the epiphyseal plates, the growth plates. Remember, at the birth, most bones are already ossified, but we will have areas where the bone growth happens, especially on these epiphyseal planes, until about 25 years before they become fully complete and fully ossified. So after that, we see far less growth in terms of the length. So throughout the childhood and adolescence, the growth plates, the epiphyseal plates play really important role. In terms of formation of the bone, there's really typically two types of ossification that we talk about: endochondral and intramembranous ossification. In endochondral ossification, what we see is that the hyaline cartilage gets replaced by the bone. So we have this primary and secondary ossification centers that really expand. Intramembranous ossification, here the fibrous connective tissue gets replaced by bone. So it's more of like, you can think of it as a little bit like a hardening of these structures. I also wanted to kind of wrap up our material this week by mentioning about bone fractures. So fracture simply refers to a break in the line of continuity of a bone. So that break can be displaced, or it can be still on the same side, but the line has broken. There's many different ways of classifying fractions. We can look at whether the ends of the bones remain aligned or become disaligned. We can also look whether the fracture is complete, so it goes all the way through that bone, or whether it's incomplete, so it's only part of the way through that bone. We could also look at whether the fracture causes the skin to be punctured, or whether the skin remains closed within that fracture site. Or we could do the classification based on the location, whether we have multiple fragments present, whether it's crushed due to the compression, for example, whether there's a twist that then breaks the bone, or whether we break it at the growth plate side, whether the bone is pushed in from where it should be, or a green stick one is really broken but not fully, like when you take a young stick or part of a tree branch that it doesn't quite break but it's still damaged. So there's a lot going on there in terms of the fractures, and I'll let you explore that a little bit more if you're interested on that topic independently. I wanted to wrap up this chapter's material by mentioning osteoporosis. In terms of the osteoporosis, a couple of things to notice there. This is where our bone breaks down at a higher rate than new bone is being made. So osteoclast activity is higher than osteoblast activity. Affects especially women related to the estrogen. So after menopause, there is a higher risk of osteoporosis for females. We see also lifestyle playing a big role. We end up seeing the effects of osteoporosis, especially at the spine and neck of femur, where we have spongy bone. Also hip bone fractures go well with that. In terms of the prevention, really the big thing is to get sufficient calcium from the diet, expose some amount of mechanical stress so we can have this build up and break up of the bone to build strong bones that you get. But as you get older, bones do become weaker. Genetics do play a role. The amount of calcium and vitamin D is worth of notice. And when we talk about the risk factors, being a female and being a white female puts you at a little higher risk of osteoporosis. The very last thing, kind of looping back, that I realized that I didn't mention, and I just want to mention it really quickly in relation to the classifications, is obviously how do we treat a fracture? We want to realign the bones and we want to immobilize them so that there's time to heal. And you'll get to see a lot more detail about that process on your lecture materials from this week. Um, I think we've done a good job of reviewing, and I'm just going to jump there to rectify this, reviewing chapter 7 material. I'm not going to go through the chapter 7 homework since it seems that we don't have a need for that. I don't have a lot of people present, and it seems like you're doing a good job of that. So maybe that's something that you're comfortable. If you get stuck, I'll be more than happy to help. As always, I am reachable for questions. All you have to do is reach out to me and I will definitely help you. But this is where I'm going to wrap up this session that we had together and this review of the material. Do let me know if you have any questions. That is a big part of my job and part that I really enjoy. So just reach out to me and we'll figure out if you have anything that's something that I can help you with. On that note, thank you for joining me. I'll make sure to post this recording for you later on the Canvas course. And as always, make it a really good week. I think this is a nice, a little more chilled out week. And next week, we'll get our first exams and practical tests out of the way. So until then, thank you. I'll see you later.